Okay, so here we are in your notebook. This was a page that you completed while you were watching your teacher be a complete silly person and giving you a lecture about DNA replication. And so that's page 79 and 80 and 80 A and B. You've already turned those in on Google Classroom yesterday, which was great. And then your next two pages, 81 and 82, should be blank. But they're not going to be blank anymore. So you're going to add this page. This page here is a zooming in image. This is supposed to be a nucleus, and this would be a really big cell around this nucleus, but we're just modeling here. So this would be a eukaryotic cell, which simply means a cell that has a nucleus, and other organelles, of course, are drawn in here in my imaginary ink. But a eukaryotic cell means it has a true nucleus. That's my dog drinking her water, making the bell sound. And a true nucleus. So these are things like plants, animals, fungi, and protists. Protists are really interesting little creatures that are a little bit like plants and a little bit like animals. They're usually one-celled. Anyway, so this page is important because what I'd like you to see is there's your DNA. This is the level of zooming in we've been paying attention to for the last 2 weeks, is this structure, this double helix, but at this zoomed in level. So what I want you to do is consider this is what gets copied when we go through DNA replication. The DNA molecule splits open, a new side is built on each of those, and what eventually happens is the individual strands then coil up and then they link to each other. So what letter N truly is replicated. I spelt that awkwardly. Replicated DNA. So what you're seeing here is one strand of DNA hooked to a second strand of DNA. That is two sister chromatids. Not sisters because they came from the same parent, just sister because in the world of genetics, we seem to always go feminine with our words. So I'm going to write two sister chromatids, T-I-D-S. Okay, so that equals one replicated strand of DNA. We call that strand of DNA a chromosome. So this is one replicated chromosome. Okay, so I want you to mount this on this page. I want you to add these notes up on the top, but I don't need you to do all of the coloring keys. That's not necessary. But I do want you to know one additional piece. I want you to look at how this DNA, when it does coil up and become a sister chromatid or one of two, it actually gets wrapped really, really tightly around these balls, these sticky balls of proteins. Those balls are called histones, and histones are an important thing to label. Histones. So I want you to make certain that you've got histones labeled, because there will be a day when I ask you what a chromosome is. And a chromosome legitimately is DNA and sticky proteins called histones. And histones play a really interesting role in how we use our DNA and when we use our DNA. So I want you to make sure you add that. Okay, so that's your page 81. Let's go over to 82. 82 is a written and typed explanation of why I asked you to watch those beautiful videos today about the flower, the salamander, the elephant and dolphin and monkey and all those creatures we saw in the bellies of their mamas on that big, super long video. And remember, I didn't need you to watch that 1 hour video. Just 5 minutes of it would be perfect. But the whole reason for that is for you to generate this idea of how did we go from one cell at the beginning of our lifetime, one cell, all the way into these multi-billion or even trillion-celled organisms. And the answer seems quite simple. It's this cell division process that makes exact copies of the original cell. So this is talking about mitosis, the cell cycle in mitosis, and why we would use it. So at the top, we're going to see where it says growth and development of organisms. This is truly a single cell dividing by mitosis and making exact copies. So you're going to read through this. You're going to look at these terrible pictures, although you can see who this is a little kid and this is a grown-up lady. This is that first fertilized cell. We call it a zygote. That is an important word. This is a big blob of cells. You can see this so beautifully in the salamander video. It was incredible. And then it was animated in the video about, let's see, I think it was this 1, 2, 3, I think it was the 5th video on today's agenda, but you'll see and remark about it. So you've got a couple of vocabulary terms that I want you to be careful of, and I want you to use this text to answer these questions, and then I want you to flip it over. Again, these are really difficult video or images to see, but I want you to understand, read, and carefully understand. This is a broken bone. This bone is in this is the humerus, so the upper arm from the elbow to the shoulder. That humerus has snapped. It's a very bad break, actually. This is a person's hand. They fell down and used their hand to stop them. So on their palm, you can see that it's all red and bloodied, but you can't see it here. They also have a little bit of an infection along the side, which is really quite gross, and it's probably good that you can't see because that's disgusting. And then you've got over here, the right image, you've got a lizard, and its little arm has been damaged, and it's growing a new arm, which is pretty cool. Down here, we're talking about just simple growth. This is an embryo, a baby that's not been born, and then a full-grown organism. And then the last one is yeast. Yeast is a interesting type of organism that doesn't do sexual reproduction. Yeast makes more of themselves simply by doing this cell cycle in mitosis. They just copy everything inside of themselves and pinch off into 2. So you're going to read this content and answer these 3 questions. Okay, that is 82A and 82B. And then 82C is blank, and that's fine. The last thing that I would like you to try, and this is the mitosis piece, and I would like you to go ahead and mount your 83A here, but I don't want you to do any of the reading just yet. And it's got flip sides, so make certain that you've got 82A and 82B. Do just a simple hinge mount. We'll come back to this on Monday. But then, a long time ago, my son and I made you a video about this page that looked like this. I asked you to cut right up the middle and then to keep the blank side, and that you had to cut all these pieces real small and tight, because what we're going to do is we're going to organize them. You just saw 2 simple, well, 1 simple and 1 a little bit more complicated video about the cell cycle and mitosis. One that I talked over and one that was professionally made. 1 second, I dropped a cell. Okay. So what your job is to try and organize them the best that you can. I want you just to see if you can put them together as carefully as you can. So like This has got X's, that's chromosomes that have been replicated. This is 2. These guys are really big. This is big. This is a little bit small. No, it's still big. This is small. That one's small. Looks like this one's 2. This one's 1 and kind of small, so it's maybe in between there. And then see if you can organize them. When you do have them organized, I would like you to then make sure that you've got them lined up properly, and you are going to mount them on this page, all in a really, really straight line, and make them fit. And then we will add a few details later today, okay? So your job right now is to build your notebook. When you're done building, you're doing these 2 pages. So you're gonna add some detail to 81 and 82s, and then you're going to leave 83 for right now, and then you're going to fully build your 84. Is this, yep, 84. Got the page down there. After this video, I will show you the next entry. I'll show you the answers so you don't take these down in the wrong order, okay? Good luck today.